Hey, so in our last target, we talked about Boyle's Law, Charles' Law, Gay-Lussac's Law, and the combined gas law. So kind of your three basic core gas laws, as well as the combined gas law. In our next target here, we're going to tackle two more gas laws. We're going to talk about Avogadro's Law and the ideal gas law. And in today's video, we're going to hit Avogadro's Law. And so our target for this particular target is to be able to use Avogadro's law and the ideal gas law to solve problems related to the amount and volume of a gas. So Avogadro's law is named after this guy. You might remember him from a previous unit that we've talked about. His name was Amedeo Avogadro, and Avogadro's law is named after him. Avogadro's law tells about the relationship between the volume of a gas and the amount of gas. Okay, so amount is a new thing we haven't dealt with in any of our other gas laws so far. The amount of a gas, we're going to use an N for amount, N for a number, and we're going to measure it in moles, right? So N for number of moles, the amount of a gas, right? Avogadro's law says V1 over N1 equals V2 over N2. So the volume 1 over the amount 1 equals volume 2 over the amount 2, right? Avogadro's law, think about a balloon, okay? And think about maybe letting some air out of a balloon. So as you let the air out, the amount of gas goes down, and then what happens to the volume? Does it go up or does it go down? Well, if you let air out of a balloon, then the volume goes down, right? If you put more air into it, the volume goes up. So, they kind of go in the same direction together. So that is Avogadro's law. Let's go ahead and let's take a look at maybe some problems having to do with Avogadro's law. Okay, here's a problem first to take a look at. It says a 25.5 liter balloon holding 3.5 moles of carbon dioxide leaks. If we're able to determine that 1.9 moles of carbon dioxide escaped before the container could be sealed, what's the new volume of the container? Okay, so here's one of our Avogadro's law problems. This one's got a little twist. It's got a little trick that you won't see in most problems, but it's really not that big of a trick. You'll see. Okay, so we've got in this problem, we've got a volume 1 we need to figure out. We've got a number of moles, 1. We've got a volume 2. And we've got a number of moles, 2. Okay, let's take a look at the problem. The first number I see, 25.5 liters, that's obviously a volume. So it's in liters. Okay, and then it says that's 3.5 moles. So that is N1, 3.5 moles. Okay, moving on, I see the next number there, 1.9 moles, but we need to read this problem carefully. This is the little tricky part. It says that 1.9 moles escaped. That's not how much is left at the end. That's how much escaped. So this is how much we had at the beginning. 1.9 moles escaped. So to figure out N2 here, I got to subtract those numbers. So I started with 3.5. I lost 1.9. How much do I have left? It should be 1.6. Not going to see that on every problem. Here they decided to make it just that much trickier, right? Then obviously we're going to look for and find volume 2. So let's go ahead and let's put those numbers into Avogadro's law and see what is volume 2. Okay, so we've got V1 over N1, so that's 25.5 over 3.5 equals V2 over N2, which is, I don't know V2, so I'm going to write V2, and N2 we just talked about is 1.6. Okay, so now to solve this, just like you did in a bunch of your other gas laws, we're going to cross multiply. So first I'll multiply this way. You got 3.5 times V2. And then I'll multiply this way. So I've got 1.6 times 25.5. Okay, got my calculator here and figure that out. 1.6 times 25.5. I got 40.8, and then we'll divide both sides by 3.5. And I got about 11.7. Okay. And my unit should be the same as the other volume, should be in liters. So there you go, not too tricky. Okay, so there's a little bit about Avogadro's law. Next time we'll talk about the ideal gas law. So until then, take it easy.